Ja, velkommen til NUUGs månedlige medlemsmøte. Veldig hyggelig å se så mange som kom hit i dag. Mitt navn er Petter Reinholdsen, og jeg er en av de som arrangerer det her. Og etter møtet så drar vi en passelig plass og får oss noe leskestrupen med og nattbit, tenker jeg. Jeg er ikke sikker på akkurat hvor vi drar. Det kommer litt an på hvor mange som blir med. Kanskje vi drar på Lorris eller et eller annet sånt, vi får se. I løpet av møtet blir jeg sende rundt en liste for å få en idé om hvor mange som var her. Veldig fint hvis dere følger dere på den. Og det var vel alle de praktiske detaljene vi trenger å ta. Maybe I should switch to English?
Yeah, it's okay. Yeah.
Yeah.
So please.
Today's topic is an interesting one, given the change of privacy laws the last few years. It's a toy project of technical developer stuck at home with kids. And it's amazing what you can get done if the kids are sleeping. So I'll leave the floor to Leon.
Can
Shift and then 2, I think.
Shift to. I think I didn't hit shift.
Okay.
Oh, that's shift.
Maybe microphone to Leon?
There we go. It's great to see so many people interested in mandatory access control in PostgreSQL, which I thought was a rather arcane topic, but yeah, once you can bring it to bear on a problem that everyone faces if they're developing information systems such as data protection and privacy, then it suddenly becomes relevant. So that's good. So a short introduction about myself. I'm Leon de Toit, as you can see from the slide, and I currently work at the University of Oslo's Center for IT, where I'm the group leader for research services. And previously I was a data scientist at Telenor. But I found that their approach to using users' data didn't quite gel with my own values. So I searched for something more meaningful. So a brief outline of what we will talk about today. First, I just want to ask the obvious question, why take data ownership seriously? And then pause on why mandatory access control, contrasting that to what one normally finds on a file system, which is discretionary access control. And then a brief introduction to this PostgreSQL module which I've made called PG Need to Know. And then we're going to work through a use case which demonstrates different features for different classes of users. So for end users, the module offers data ownership, insight into how your data is being used, and the possibility of it being only used when you consent to it. We'll extend a bit on why that is a possibility. And then for administrators, it offers fine-grained access control and extensive audit information. And lastly, for developers, you have a rich REST API which you can use to build your application, and you have a built-in authorization model. So you don't have to worry about that. And then if there is time and appetite, we can look at some implementation details. So why take data ownership seriously? Well, in a banal sense, because of the regulations of the GDPR. In a less banal sense, because it's about respecting people. If we just pause on the GDPR, we know that it has increased the focus on data privacy and protection. People have to take it seriously, because if you don't and you get caught, then you get a huge fine. The GDPR also promises end users the right to access, so that you should always, as an end user, retain access to your data once you've given it to a data processor. And you should have insight into how your data is being used. You should also have the right to be forgotten and the right to have data portability, which in practice means being able to download your data and upload it somewhere else. And data usage should be based on explicit consent. And lastly, all of these things have brought an increased demand for audit information. So previously, where that was an afterthought, it is often now a strong requirement that your system generates audit information. So these are all quite hard problems to solve in complex architectures. So why mandatory access control? Well, it's about creating enforceable policies. So as an administrator, you don't want your users to be able to bypass your security policies. In the case of discretionary access control, users can often bypass that because they have certain rights to begin with. So a classic case would be someone adding themselves to a group because they have the permission to alter group membership, and then suddenly they expand their own rights. Having mandatory access control really enables you to do data access based on consent. So when you connect your security policy to explicit consent, then you actually enforce the consent. It's not just a promise that you make, which you then have to keep, and which you do keep if you are a good person. This makes it a little bit easier to force yourself into using consent-based data access. And then it also, PG need to know, supports granular access needs, because often in a database your data is scattered across different tables, but the data might belong to the same person. So how do we enforce this policy across tables and across rows within tables? This is also a tricky problem to solve, and is not something that you get out of the box, especially if you're thinking about developing a web application. So a little bit about PG need to know. It is a PostgreSQL module. I put it in inverted commas because really it's just a set of tables, views, and functions. One could package that up into a PostgreSQL extension, but really an extension is just a set of tables, views, and functions. So there's no need to mystify this. It implements mandatory access control, which means that once administrators use the module to set up security policies, users cannot bypass them unless there is a bug in the implementation, which I don't think there is, but it's also possible that my test coverage isn't good enough. It is a much more limited approach than, for example, SE PostgreSQL. SE PostgreSQL is a project which integrates PostgreSQL with security-enhanced Linux, so that you use your SE Linux as it goes. You use your SE Linux policies in your database. This is a much more comprehensive and heavy-handed approach, and perhaps too much if your aim is to develop a web application. And I also only had 3.5 months of permission, so I didn't want to have to understand SE Linux completely before I could get coding. So I was looking for something that was possible to finish within a couple of months in really strange intervals, 1 hour at a time.
When the baby lets you.
Yes, exactly. So I chose something more lightweight. The source code is available on GitHub. It is written in PL/PGSQL, which is a procedural language that ships with Postgres, and it extends SQL with control structures. So you have control flow, loops, exceptions, error handling, everything that you would expect from a programming language. It is still quite minimal and can sometimes feel a bit strange because you're kind of like in a SQL mode, but not really in a programming language mode, and you're executing it in the database. But once you get used to it, it's really quite fun. It's used to create functions, so the basic unit of code organization is a function. And then in total, the implementation turned out to be 1,000 lines of source code, so it's really quite small. And then 1,500 for tests. Of course, I could have made my lines longer or been more terse, and then it would have been less lines of code. But this gives you an idea that it's the kind of project that can easily fit into your head. And interestingly, it uses row-level security policies to implement the mandatory access control. And this is really the cool part and kind of the reason why I did it, because some years ago, I learned that Postgres added row-level security. And then I was like, cool, I really want to use this. But I never had a use case which was worth the effort. And finally, I saw an opportunity to use it. So I was very happy that I could do that. And then lastly, it's important to know when you look at the module that it is designed to be used via a REST API. And I'll explain why as we go along. It is also possible to use it with the SQL functions, but it is less secure if you do. So let's just pause briefly on row-level security. It was introduced in Postgres 9.5. The current version of Postgres is 11, so it's a couple of years ago. And it has been evolving with subsequent releases. And think of it as a policy expression which is evaluated during the query execution for each row. One or more policies. So it is almost like a trigger function, except this can also be executed on select statements. Trigger functions have this annoying limitation that they can't be executed on select statements. And you can use the values of the current row as inputs to functions which implement your security policies. And it works in a very simple way. If your function evaluates to true, then the row is returned into the result set. And if it evaluates to false, then it is not. And you're using a Postgres extension called create policy. So let's just go through this line by line. We'll see that it is quite simple. You create a policy and you attach it to a table. Skipping the second line for now, you see that you can specify which SQL statement you want the policy to be triggered on. Either all statements or select, insert, update, or delete exclusively. You can optionally assign the policy to a specific database role so that the policy is only triggered when this specific role is executing that specific statement. And then you have two different types of expressions which you can invoke. So you can alter the scope of your policy and customize it for certain scenarios. And then jumping back to the permissive versus restrictive, all policies are by definition permissive, which means that if you have multiple policies, they will be combined with an OR expression, which then implies that if any one of them returns true for the current row, then you will be able to see the data. If it is restrictive, then it is combined with an AND expression, which means that if any one of them returns false, then you can't see the data. So you can also use this to design your implementation. So you have a lot to work with. Okay, now getting towards the module itself. 3 key terms to remember. And these are kind of my own terms which I developed. And so there's the data owner, which is any person that provides the system or the service data about themselves. So typically what you would call an end user. And then there is the data user, which is someone that analyzes data about other people. So a data scientist working at the company, for example, or a researcher working in a project. And then the administrator. And the administrator is someone that sets up access control policies. So you have these 3 roles who are involved. And let's assume we have the following setup. We have 6 data owners, A, B, C, D, E, and F, and 3 data users, X, Y, and Z. And we're going to collect data about spending habits and the personal details of the people whose spending habits we want to study. So we have 2 tables. And both of these tables contain data from everyone. And our challenge is to set up 2 access control rules in our database. The first one is that data users X and Y should only have access to data in table spending habits. So they're not allowed to see the personal details of the people. And they're only allowed to see data from user A, B, C, and D. And then we have someone with full access, user Z, which should have access to all tables and data from all owners. So if someone were to present this challenge to you, and if all you had was a clean database, this is quite a daunting task to implement. And that is also why I wanted to make the module, because it's annoying to do this kind of thing again and again. And it's annoying to have this logic re-implemented in many different web services, when it's not arguably the business of the web service to care about that. It should be something that an API provides to a web service, so that developers can think about other things. So a hypothetical sequence of events for how we can use this module to achieve that. We'll go through this. An admin creates tables. Data owners and data users register themselves with the system. Data is collected. The admin creates groups, adds members to the group, and adds table grants. Then data is analyzed. People make profit, people publish papers, it's wonderful. And then users manage their own data, exercising the rights given to them by the GDPR. And admins get audit insights when the people who they are accountable to ask for it. And then this is kind of actually step 0. Developers create applications using these features. But I don't really want to talk about application development here, so I'm just going to briefly mention that at the end. So let's just look at table creation. So I've taken a snapshot of what happens in the database when you create a table. So it's not really very mystical. You send a JSON structure specifying a table definition. So if we look at the top level keys, you have table name, and then just the name of the table, and then an array of columns, each of which is a dictionary with a name, a type, and a description, which is optional. And then lastly, you have another optional table description. So you can add metadata to all of your objects. And I've taken great care to avoid SQL injection in this and all functions. That's also the great thing about the procedural language PL/PGSQL. It gives you very powerful tools to defend against such classic attacks. Then a table is created. As for user registration, there's nothing much to demo. People register themselves with the system. At this step, we can also require consent before registering data owners. So now this would be left to another application, because I didn't want to implement a consent system. That's not the point of this. But if you have such a system for collecting consents and linking that to projects or users, this would be the point at which you stop someone and say, hello, I'm going to do this study and I want to do this and this with your data. Do you consent to it? And then we can fetch that later and integrate it with the access control. And then crucially, data collection isn't possible without registration. Why is this crucial? Because how can you enforce ownership if you don't know who the people are? So this is definitely not a service for, I guess you could use anonymous identities. Then something else would have to anonymize people in a consistent way. Okay, let's shelve that digression. Okay, so what are you actually doing when you implement this access control? You are creating groups and adding members to the groups, and you're granting these groups access to tables. So I mentioned again that you can link consents to groups via group metadata. So this is a very loose coupling, for example. When you create your group, you can say, this group is covered by consent A and consent B. And then you can keep track of that somewhere. So here, remembering our policies, we will have group 1 with 2 analysts, X and Y, and they have access to data from A, B, C, and D. But they're only allowed to see spending habits. And they get a PG need to know gives you the ability to grant specific access on the table. So you can say, this group can do select, or this group can do select and update, or select and delete. So it's only giving the permissions that are necessary. And then group 2 has access to everything. So now for the data analysis. So let's unpack this. The first line there is really important. It says set session, and then there's some string, and then a value user X. Now this is really the job of the web application or the REST API that presents PG need to know's functionality. It has to learn the identity of the person who is requesting data and then pass that information to the module. And it does so using a session variable, which lasts for the duration of the connection and the transaction. So I just select the current setting to show you that this is something that is stored in this session. And then if you do a select star from spending habits, you can notice that user X only sees rows belonging to A, B, C, and D, even though there's more data. We can look at this table a bit. Every row has a unique row ID, which is generated by PG need to know. You'll see this is used in the audit tables as a way to reference to specific rows. And then we have a concept of a row owner, which is the person who owns the data, and a row originator. And by default, these two are the same, but they need not be. Because you might go and analyze something and then store your data back, and then this data might not actually belong to you, because you might be analyzing data about someone else. So you can then say that I am originating this data, but it doesn't belong to me. And then the security policies will pick up what that means for access control. And then we see that user X tries to select from personal details, but gets an access denied error. So this is wonderful. If you're using this from a web application, you're guaranteed that this user won't get access to data that they're not allowed to see. You don't have to worry, oh my goodness, did I construct the query in the correct way? Is there a bug in that? Because if you pass a blanket select to the table, you still won't get anything. It will be inefficient, perhaps, but it won't be wrong. As for user Z, you can see that they have access to everything. So we can compare the data in spending habits for user Z to the previous one. We see here that only data from A, B, C, and D is visible, but here E and F are also visible. So for me, this was like the first thing. Seeing this was like a wow moment, like, oh, satisfaction. As for data ownership, what does that mean? Well, taking, yeah.
I was just wondering, does that mean that do you have column control, so you can select which columns they can access on the different rows? Or?
That is possible, but I didn't implement that. I guess I'm kind of waiting for someone to ask for it before I do. The nasty thing about that is kind of a user experience thing, is that if you then do select star, you won't get anything because it's not smart enough to only return the columns that you have access to. Unless you then make a function which wraps a select and catches that specific error and then figures out which column you don't have access to and then removes that from the select and then constructs one.
So it's fiddly.
I guess what I had to decide at that point was, is this useful enough for people to design their access control around? And I think I would then argue against implementing the feature and say, just design your tables differently. Take these two columns out to a different table. And
put the more sensitive data in a separate table, and
yeah.
the user will, most users will agree that that data is less sensitive and this is more sensitive.
Yeah,
So
for example.
it's only when you've got complicated variability between users to which bits they are more
Yeah.
concerned about keeping private.
Yeah. Yeah. But yeah, that did come up during the design phase. So going back to data ownership, because this is really the connection with the GDPR. It means right to access, so you should always have access to your data and only your data, crucially. And then data portability, so that you can take your data elsewhere, and then the right to be forgotten. And this right to be forgotten thing is a major headache to do. So right to access, so we do exactly what we did before, but now we're not in the role of an analyst, but in the role of an end user, and that is owner A. So a request comes in, you are owner A, you try to select everything from the tables, but you only get your own data. That's nice. Data portability is very simple. You did what you did here, and then you get your data. Right to be forgotten. So if you look, so here in the beginning, I'm just repeating what I did before, showing that there is data, and then immediately I'm doing a select user delete data, and this function picks up who is the current user, and then it scans all tables and removes all rows belonging to that user from all tables. And so after that, this user tries to select data again, and then you can see here that there's nothing left.
Except for these tables testing in test 1.
Yeah, that was an oversight. I guess that's sort of an ugly thing, but it's not wrong. It just, those tables, were also created by the admin, and this person doesn't have access to those through the group permissions.
But you spoke about the owner, but if you spoke about the owner, but what about the originator? So he can import data and then can never ever access it?
Potentially, yes.
I need to think about this. No, you can't. I mean, we can talk about implementing that. I guess let's say you're an analyst, you find out someone has a weird mutation and you want to let them know, and then you publish data about them. And then they look at their data and then, well, I guess, let's talk about this tomorrow. We're colleagues, so we can sort this out. Okay, moving on. Audit insights. So we've seen a lot of things happen now. We've collected data, we've made groups, added users to those groups. Analysts or researchers have been looking at data. People have been looking at their own data, deleting their own data. We need to keep track of all of these things. And we don't really want to contact the database group and ask them to increase the log level on their SQL database and keep the files and parse the files and ship them to another logging solution. No. As an application developer, you just want to have that available by default so that you can work with it without talking to anyone. So you have that. So data access, so each time a select is done on a row, we record when it happened, which table it happened in, which row ID was being accessed, by who, about who. So you can use this row ID in combination with the table name to then determine exactly what data has been seen by this person about that person when. And this is the classic thing that privacy officers want to know. And the great thing about this table is, as an administrator, yeah.
When is that access kept till, is it actually finally deleted?
Could
Or is-
you repeat the question for the recording?
What about the information access of that? When is that finally deleted or kept? That's still personal data, really.
This here.
Like, who's seen what data? Is that kept for forever, or is that at some point deleted also?
I also thought about that, and then I thought I could have a trigger function which looks at the request time every time a request is done, and then if it is older than X days, it is removed. But then I didn't really have enough time, and then I thought, I don't really know what people will want there yet. Yeah. But it is definitely possible to enforce something like that. And I don't think it would be difficult. It would be a small feature to add. Yeah, it's a good question, and it's also an important part of auditing. Oh, right. What I was going to say is that the admin can see everything here, but the data owners, they can only see what pertains to them. So if I gave data to the platform, I can also look at this data access auditing log, but I can only see who accessed my data. Access control changes. This is also important to trace. How did we get to the status quo? What kind of, I mean, if you're paranoid, you want to check up on your sysadmins as well. And this allows you to do that. So you can see what policies have been implemented here. So we can see, for example, in the event type column, 2 group create events, and then a whole bunch of member add events, and then table grants. And I mean, I only had my own ideas available here, and I'm sure a lot of people have ideas for more auditing here and different types of events. So I implemented the bare minimum. And then when the user deleted their own, this wasn't actually implemented, but you can remove yourself from a group as well. So let's say you consented to 2 studies, and then later on you decide, oh no, I don't want people to continue studying me here, but they can continue studying me there. Then you can revoke your consent, for example, and that would then also trigger in PG need to know that you are removing yourself from a group. And this would be recorded in this log that owner A removed themselves from a group. We could then perhaps implement additional features where you could specify permanent, temporary, or so on. Yeah. Mike?
This one gets tricky because, first of all, that doesn't say who did the removal.
The user themselves.
Okay, that table only has the user-initiated one. But then there's, of course, the fact that who's got access to the information that this user removed themselves from this group on this date?
Only the admin.
Only the admin. Okay, yeah.
Okay. And then data deletions are also recorded so that you can see when someone acted on their right to be forgotten. And then this one is a little bit small, but if ever you change data, then we also record what the old value was and what the new value is. So this is sort of a provenance feature. Okay, we're nearing the end. So let's talk a little bit about application development. So if you're a web developer and you want to use this, you would have PG need to know installed in your database and a REST API exposing all of this functionality to your app. You could also choose, of course, to implement your own REST API talking to the database using these functions yourself. But that would be more work, or just up to yourself. The point is that developers can focus on business logic. So why implement all of this access control in 5 different web apps? It doesn't make sense. And authorization is taken care of, but authentication is left to the web app implementer. So you have to figure out your own IDP and authentication. I designed this to be used with a specific component called postgrest, which I really like. It is an open source project written in Haskell, and it provides a REST API for any Postgres database. If you choose to use this, then this link here will take you to the HTTP API that you get with this module. One thing to know is that you require a custom build of this server due to the audit logging. This is an obscure thing, but PostgreSQL executes all GET requests as read-only in the database because the semantics of HTTP GET is that you are not modifying a resource, which is correct. But I have an insert trigger whenever you are accessing data, and insert violates the semantics of read-only transaction. So I edit the source code and compile my own to break that because I think it's worth it.
Can you just repeat that? I've had a long day since 5 a.m. Can you just say that last couple sentences? That I was done.
Okay, she asked me to repeat it. So the REST API gives you HTTP methods such as get, put, post, and so on. And in the semantics of those methods, get is a read transaction, which doesn't modify a resource. And postgrest is right to respect that. So whenever they execute a query in the database that is initiated by a GET request, they do so in a read-only transaction. And this is something that you can set when you are executing a query in a database, what type of transaction you want, read-only or read-write. And because they do that, I can't modify anything in the database when you're doing a GET request, which means that I can't do audit logging in the way that I want to. And I spent many days on this and spoke to the developers as well and tried to get them to relax their assumption, but I agreed with them and then I just compiled my own. So at least in their user base, it doesn't seem to have been a problem before. Yeah, it was luckily just one line to change. So I didn't have to learn Haskell to do that. I was like, oh man, this is going to be a costly change. Oh, anyway. So 5 minutes left. As for authentication requirements, if you're making a web app that uses this, you must provide an access token at request time. It has to be a JSON Web Token with 3 claims, an expiry time, a role, which is one of the 3 roles which we discussed, and then a username. And the username is the one that is generated by PG&E to know when you register. So if you were implementing your own, you would have to fetch this from there. I have implemented a token endpoint, at least to help you get started, but it's quite possible that one would want to implement their own. And then I made a reference client for the HTTP API in Python. I still had some permission left, so I mean, what are you going to do? So if you want to have a look, this is also a good place to start. Anyway, okay, enough about the reference client. And then actually, I've been timing this, we have 6 minutes left. So we can look at an example table definition just quickly, just to demystify it a bit. So we have all of these row level security policies and all of these things, but what does the table definition actually look like? So normally a table definition doesn't contain much, but here the data part is really quite small and the rest is quite big. But let's just look at the first 3 rows, columns. Row ID, row owner, and row originator. So all of them are not nullable because we need that information to ensure that access control works. All of them have default values. The row ID is by default a UUID, and the other 2 by default the session user. And then we have a check constraint on the row originator, which checks that it is actually equal to the session user, so that you can't explicitly provide a value to it and fake it. And then we have 2 foreign key constraints. We check that you are actually a registered user for both the row originator and the row owner. And this makes sure that you can't insert data if you haven't registered yourself. And then we have policies. We have a select policy, 2 update policies, a delete policy, an insert policy. We have 2 select policies. The one select policy is only applicable to data users, and the other select policy runs for everyone. And we've already talked about what these policies do, so we don't have to stare more at that SQL. And then lastly, we have 2 triggers. And the first one is called an immutable trigger. And what I wanted to do here is I wanted to ensure that the columns that implement the security cannot be modified once they are set. So that you can't, once you become a row owner, start, giving data to someone else or something. So once they are set, you cannot change them. And Milan, that's probably back to your point. But and then an update trigger, and you can just see that that's where we log the change in the data. So if you want more information about this, I recorded this demo which produced the screenshots in an ASCII cast. So you can go to that URL and then you can watch it executing and just press pause to see like how all of the steps work. You can read the docs, and then this presentation and all of the materials for it are available in that repository on GitHub. Thank you.
Any questions?
Actually, that was really interesting when you were going through a couple of, weird. I actually thought what you were saying a few lines before going through what you did on your code was interesting, but you stopped going through it, so.
I did write about it in the documentation more extensively. Okay then.
Well, if nobody else has any questions, I think we just thank you for your presentation. Yeah.
Let there be beer.